Okay, this is section 1.3, linear functions. I'm going to do a little video lesson on this. Okay, linear functions, I know you've been over them before in algebra. We're going to go over them again in pre-calc here. And we have a little different way of writing them sometimes, but don't get messed up by that. It's this f of x notation. It's called function notation. And it just means when this x, the value we're evaluating in the function, this x value just goes right here. So you can think of it as just being y if you want. So f of x and y are the same thing. Whatever value of x this is here goes into the x on this side of the equation over here. Remember, with the solution to a linear function is called an ordered pair. This is the x and the y. The x always comes first. They go in alphabetical order, and they're a solution to this equation. Okay, if I put an x in here, I get the same y out every time. Okay, so an example for this, remember this is just y is the same as f of x equals 3x plus 6. You're more familiar with the y notation, but function notation, the same thing. So they have these 2 points, and the solutions are if x is 0, then y equals 6. If x is -1, then y equals 3. In function notation, that would look like this. F of 0 would equal 6, and f of -1 would equal 3. Okay, so that's the function notation. If I evaluate my function with x, x equals 1, I get 3. Okay, so if I evaluate it with x equals 0, then I get 6. All right, I'm a little trouble with the ink here. Okay, so graphing the line, no trouble with that. Graphing it, we just have to get a few points here, right? So the points are where we want to usually do the easy points. So the graph got a few points here, some x and y's that worked with this equation. Plotted them on the graph, connected the dots, made a straight line. So that's a nice linear equation. Okay, graphing on the calculators. If you don't know how to do that, I'll just go over that in class when I have the screen up. It's a little easier to show you when I have my calculator simulator doing that. So I'm not going to go over it here. When you graph the x-intercepts, the y-intercepts, and zeros of the function, okay, we'll go kind of review that. The x-intercept, let y equal 0 and solve for x. Okay, so that's not too hard to do. Same the y-intercept. This is where the x-intercept, if I make a little graph here, it's where it crosses the x-axis. If I just like draw a line there, the x-intercept's right here, wherever it crosses the x-axis. Same thing for the y. If I was drawing a line, the y-intercept would be wherever it crosses the y-intercept, and that's where x equals 0. Okay, x equals 0, that's my y-intercept, and y equals 0, that's my x-intercept. And also the 0 of a function. You may or may not have talked about that in algebra, probably not, but it's where the answer, remember this is the function notation, so it's again where y equals 0. Okay, so where did we see that before? Well, we saw it right up here, right? Y equals 0. So the x-intercept and the 0 of the function are the same thing. Okay, so they're the same. And you only need 2 points to determine a line. Remember that from geometry. And if these 2 points is one's the x-intercept and y's intercept, then it makes a nice graph. It's easy to graph it then. So we have 2 intercepts. We can graph it. This one, of course, is this one is the y-intercept, and this one is the x-intercept, where it crosses the x-axis, and this is where this one crosses the y-axis, right? So that's what those 2 intercepts are. Applications of this, remember that the slope is a rate of things. So if you have a rate of something, that's the slope. Okay, so what is a linear function that models this problem? Well, if the rate's the slope, okay, so my rate is going to be 5 if I'm taking water in or I'm taking water out. So is this going to be a positive rate or negative rate? Well, normally when we take stuff out, we consider that negative. So we would write this as f of x or y. Remember the same thing. Y equals the f of x, right? And we would get this function where it's negative 5 gallons per minute. We're taking 5 gallons a minute out. We started with 100 gallons. How much is left after 4 minutes? Well, in function notation, we'd write it like this. F of 4 equals, and then we would do not 55 times 4. It's just 5 times 4. I don't know why they had that there. That's a little typo. It's just negative 5 times 4 plus 100 equals 80 gallons. That's how much water is left in the tank. So negative 20 plus 100 is 80 gallons. X and Y intercepts on this one. Well, if X is 0, that's the Y-intercept. Okay, so X is 0, that's where we start, 100 gallons in it. And where Y equals 0, that's where the tank is empty. That'd be the X-intercept. And it's empty when it would take 20 minutes to empty the tank, right? The constant function, remember this is also y, it's a straight horizontal line, constant function. The value is always constant on the function, it doesn't change, doesn't go up and down. So that equals y. It's a horizontal line. The y-intercept is the same as whatever this value is. In this case is going to be negative 3 on this example. The domain, the x values are positive, negative to positive infinity. The range is just one number, whatever this is. In this case, negative 3. Okay, so different, make sure when you graph these, I'll show you this in class, so you have to get the windows to be, you want to show both intercepts on the graph when you're doing it on the calculator. This would not be a good way to look at it. You couldn't see the y-intercept. You want to see the x and the y-intercepts on these linear equations on your calculator. Slope of a line on this one, they just kind of graphed these 2 points and connected them and made a line for it. Then remember to get figure out the slope, it's just, the rise divided by the run. We're going to talk about there on this next slide. And, this is the y values here. It's how far up or down it goes. And this is how far left or right it goes, rise over the run. Okay, also we use in pre-calculus, we use this delta notation, which means the change in y and over the change in x. So in this case, our delta y is the difference between the y numbers, y2 minus y1, and the difference, y2 and y1, sorry, over here. And the difference between the x numbers is the horizontal distance. And that forms a slope, which they use the letter m for that. Okay, so they show you how to do the slope on these 2 points. You've done this before. You just subtract the 2 y numbers on top and the x numbers on the bottom. And it doesn't really matter which one is y1 and which one is y2. I'll do it for you the opposite way they did it. You'll get the same answer, right? So if we do that here, we get -1 minus 3. Those are our y numbers, right? -1 and 3 over the x numbers. So I'm going to do the same order that I did. I started with the left point, so I'm going to do 2 minus a -5. So on the top I get -4. On the bottom here, remember if I have two negatives, it makes a plus, so that's going to be 2 plus 5 gives me -4 over 7. Now it doesn't really matter whether the negative on a fraction is on the top, bottom, or in the middle. It's just a negative fraction. Okay, so same answer they got there. Use an example of the slope point, graph a line that passes through those 2 points. So to graph that line, you start at the point. Right here, they started the point, then they went, this is the rise number, so it's negative, so we're usually going to go down. So they went down 4. First thing you do is go down 4. And then they went over 3 and found a new point, right? The -5, -3, and just connected the 2 dots. So it's easy to do if you're graphing it that way. Okay, so find the equation of a line that passes this. Sometimes you have to do that. And so the equation of a line, you can just go back to the old y equals mx plus b. Oh, my thing isn't working too good right now. So but we know that this is my x and this is my y, and this slope is the m. Okay, so I plug those values in. For y, I get 1. It's not letting me. Okay, so sorry, I had a little trouble with the pen here. So y equals 1 equals, my slope is -4 over 3, and my x value is 2, and I don't know what my b value is. Okay, I don't know what b is. That's what I'm trying. That's what you try to figure out on this. Use y equals mx. There should be a plus there, plus b. So we use this to figure out what b is. We know the y, we know the m, we know the x, we know everything but b. So we use this to figure out what that is. So we get 1 equals -4/8. Oh, not 4/8. We get negative. I keep writing 4. Erase all that. Okay, so what I really wanted to write was -8/3, but you knew that anyway, right? Plus b. Okay, so I just multiplied 2, -4 times 2, and got this fraction. Then I add 8/3 to both sides. Remember that's 1 is, can rewrite that as 3 3s plus 8/3 equals b, which equals 11/3. Okay, so now what do I do with this b to write my equation? Well, I come up here to the equation. I put that's the slope, right? That goes in there. So normally we would write it like this: y equals, I know what the slope is, -4/3, and I put my x in there, and now I know my b number is going to be 11/3. So that's my equation of the line that goes through this, has this slope, and passes through that point. Slopes of horizontal and vertical lines, of course, the if it's horizontal line, this one would be whatever y value it is. So this has a slope of 0. And this one, this example I gave us, y would equal positive 4. If we have a vertical line, the slope is undefined because we're trying to divide by 0 here. So that gives us an undefined answer for the slope. And it's just a vertical line where all the x's are the same. In this case, it would be x equals 4. Okay, so vertical line going through 4. There's no slope, it's undefined. Slope-intercept form, we've already been over that. Y equals mx plus b, same thing. They emphasize it here that these two are exactly the same, right? F of x and y are the same. And one last little conundrum here, a little problem. Which one is which? Matching which one goes with which should not be too bad. Remember, if it goes down, left to right, it's going down. That's a negative slope. Left to right going up, it's a positive slope. We have one positive slope, so that one positive slope is going to be this one, right? The positive slope is that one, so that one has to be C. Okay, so number one has to be C as long as it has the positive slope. These other two have negative slopes, but they have different intercepts, right? The second one has an intercept of +3. So we look at these ones, which one crosses the y-axis at +3? Well, that one. So that one's got to be A. And of course, by process of elimination, but we'll just look at it again. Y-intercept is -3. -3 is the y-intercept there, so that's got to be B. Okay, without doing too much work, that's what the answers are. Okay, so I think that's about it for this slide. Oh, I'm not going to do this one. Yeah, don't worry about that one. And that should be it for this, if I can get it to stop. Why does it want to stop here? All right, finally get it to stop.